Okay, so to use synthetic division, the divisor must be something like x plus 3 or x minus 5. So the coefficient of the divisor has to be 1, and the exponent of the divisor has to be 1. Alright, so on this one, sorry, I changed the problem on your paper, but I didn't change it on here. Alright. So because we're dividing by just x minus 6, we can do synthetic division. So let's see what you guys can remember. So when you do synthetic division, you do this little box. So if we're dividing by x minus 6, do you guys remember what goes in the box? It has to do with the x minus 6. Is it going to be 6? Is it going to be negative 6? It's positive 6. So you do the opposite. So if you're dividing by x minus 6 in the box, you're going to do a positive 6. And then to the right of the box, you're going to do your coefficients and your constants of the dividend. You're not going to put any x's in there. You're just going to put numbers. There is one other thing you have to watch out for. So if one of the powers is skipped, like it goes from x to the fourth to x to the second, or in this case, x to the second to just the constant, you have to fill in a 0 for whatever was skipped in the place where it would have been. So if you don't do that, you're not doing the right division problem. So we're good now. So we would write 10, negative 50, negative 62, 0, and then 70. Right, then you're going to leave some space and draw a horizontal line. This very first coefficient comes straight down. Right, and then you're just going to multiply and add. So you multiply the number in the box by the number under the line, and it goes under the next number, 60. And then you're going to add. You add these two together. Negative 50 plus 60 is 10. All right, then you're going to multiply the number in the box by the number under the line. And then you're going to add, and you get negative 2. And we're just going to keep on multiplying and adding, multiplying and adding. Now I always separate the last number from the rest of them. Do you guys remember what that last number is? That's the remainder. And so our answers are going to look the same as they did on the previous lesson. So all of our answers are going to look like this or like this. So what we have here are the coefficients, the constant, and the remainder of your answer. So we just need to go back and fill in the x values. And so if I took an x to the fourth and I divided it by an x, it should be x to what power? 3. So this right here, this 10, I'm going to see if I can fit it underneath it. That 10 is going to be 10x cubed. So this power is always 1 less than that power. All right, and then plus, then the next 10 is 10x squared minus 2x minus 12, then minus your remainder over the divisor, which was x minus 6. Sorry, I had to squeeze it in there. Okay, so the answers look the same as they did the previous lesson. We're still dividing polynomials. It's just a very much of a shorter way to get there. Alright, so let's try another one. Do you see any issues with this, the way this is set up? Yeah, and If it's out of order, you have to fix the order, or again, you're doing the wrong division problem. So we would change it to 4x cubed plus 8x squared minus 9x minus 18. And then because I'm just dividing by x plus 2, I can do synthetic division, where I'm going to put negative 2 in the box. Do I need to fill in any zeros on this one? Nope. Alright, so that 4 gets dropped down, and then we just start multiplying and adding. So negative 2 times 4 is negative 8. Then I'm going to add and get 0. Don't worry, 0 is fine. We're going to do negative 2 times 0 is 0. Then we're going to add and get negative 9. And then 2 times negative 9 is 18. And then we'll add and get 0. This one had a lot of zeros. So when I go to write my answer, I started off with an x cubed, so I know that this is going to be 4x squared. There's not going to be an x term, and then it will be minus 9, and then there's also not going to be a remainder, so that's it. You guys want to try one on your own? I'm going to have you guys try the last one on your own, so I'll just let you work ahead of me, and then you can check as you go with mine. Are doing this on your own and you ever just want to double check, like if you don't have the answers or whatever, if you plugged negative 3 into this, the answer should be whatever the remainder is. So we could try it, but same thing here. Like if I put 6 into x on this function, that I should get negative 2. So that's like the factor or the remainder theorem or something like that. And we're also going to talk about the factor theorem. Is everyone good on part C? Okay, so the factor theorem kind of uses the remainder theorem too. So if a polynomial has this as a factor, you should be able to plug in this value and get 0, which means that the remainder is 0 whenever you divide. And hopefully that makes sense to you. If you divide something by its factor, it goes in evenly, so there is no remainder. Alright, so this example is going to use a whole bunch of your algebra skills to do all the things. And so the first one is the new one. All the rest are things we've done before. So the first one, we're going to verify these factors. And so we want to be able to divide them and get a remainder of 0. So for a factor of x minus 5, can I do synthetic division? Yes. As long as there's no number in front of the x, then there's no power. I can do synthetic division. What would I put in the box? Right. Do I need to fill in any zeros? Nope. So I'll bring down the 1, and then I'm just going to start multiplying and adding. Verify it when you do the division and you get a remainder of 0. Now, if you're one of the people that work ahead, hold on just a second. We can do synthetic division to check for x plus 4. We would do -4. But we don't have to go back to the original problem. Since I got a remainder of 0, I can just use these numbers, a shorter version, and make sure I get a remainder of 0. That's called using the depressed polynomial to verify, and that's fine. So when I use the shortened version, I still got a remainder of 0 for checking x plus 4, so we're good. We've done part A. We verified the factors. Okay, part B asks us to find the remaining factors. And so to find the remaining factors, we're going to use these numbers. And so it started off as a quartic, x to the 4th. I did synthetic division once, and it changed it to a cubic. And then when I do synthetic division again, what should it change it to? Squared, a quadratic. So this is going to be 1x squared minus 3x plus 2. So to find the remaining factors of f, I just need to factor that. Alright, and this is where my last class started getting confused. They think they can't factor, but they can. You guys can do it too. So x squared obviously is going to be x and x. This plus sign, what does it tell you about these? Right. This plus tells you they're the same, and then that tells you what they are. They're both going to be negative. Good job. And we're going to multiply to get 2 and add to get 3. Yeah. So those are the remaining factors of f. Alright. And then C wants us to find the complete factorization of f. So we would write f completely factored form. You're going to take the 2 factors that we verified, and then the remaining factors that we found. That's the complete factorization of f. So if you multiply all that out, you would get x to the 4th minus 4x cubed minus 15x squared plus 58x minus 40. I don't recommend it, just trust me, it does. Alright, and then D wants us to list all the zeros. Alright, so we've done this, but it's been a little while. So if x minus 5 is a factor, what is the 0? 5. And then -4, and then 1, and then 2. Alright, any questions on that one? Y'all are doing great. This last one's a bit of a challenge, especially since it's been so long since we learned something we need. Some of you haven't learned it yet, but it'll be okay. Okay, so looking at this one, we're going to verify these factors. Can I do synthetic division? No. I'm going to do long division. Now, I personally like long division just fine. But synthetic is way, way shorter. Okay, when you do long division, you kind of have to talk to yourself. Sorry. It's okay. You'll be fine. Just talk to yourself in your head. So, we only care about the first two terms. And so you have to ask yourself, what do you multiply 2x by to get 6x cubed? 3x squared, good. And I like to line it all up. You don't have to line it up on the top. It just, I don't know, that's what I like to do. Bless you. But you do have to line it up on the next step. So your next step is to multiply, where we're going to take that 3x and distribute it to the whole 2x plus 1. So 3x squared times 2x gives us our 6x cubed that we needed. And then 3x squared times 1 is obviously 3x squared. And you line up your like terms. And then if you're going to make a mistake, it's probably here. We have to subtract, but make sure you subtract both of these. So you change both of the signs. The 6x cubed subtracts away, and then you're just left with 38x squared. Alright, and then your next step is to bring down. And then you do it all over again. But we only care, when you do the divide step, you only care about 2x and 38x squared. So what do you multiply 2x by to get 38x squared?
16x.
That's what I said last class. It's not 16. It's 19x. It's alright.
I'll put 32 on there.
Oh, alright. Alright, and then you're going to multiply 19x by both of those. And then we're going to make sure that we change both signs. So we subtract the 38x squared and the 19. Alright, the 38x squares cancel out. And then we have negative 28x. And we write down the minus 14. And then we just have to do it one more time. That should be a negative 7. Just kidding. It should be a negative 14.
Yeah, it's so confusing.
Alright, and so this time when I changed it, when I subtract, I actually changed them both to addition signs. And I get my remainder 0, so it checks out. So that's long division, for those of you that missed it. Alright, we have another one to check. We need to check 3x minus 2. And I'm going to do the shorter version. So I'm going to take the 3x minus 2 and divide it into this right here. It'll save us a little bit too. So we just start off with 3x divided into 3x squared, or when you multiply, and that's going to be x. And then when we multiply, we get 3x squared minus 2x. And then we'll change both signs. That subtracts away, and we have 21. 21x. Break down the minus 14. And then that should be a plus 7, and we'll be done once we finish it out. Okay, so we got our remainder of 0. So on the last question, when we got to part B, we had a quadratic. We had x squared minus 3x plus 2 that we needed to factor. This time, when I get to part B, I have x plus 7. Does x plus 7 factor? No. X plus 7 is our remaining factor. So that's it. We're done with B. So you only have to do the factoring step on B if it's a quadratic. If it's linear, you're done. And we're ready for part C, which is to write the complete factorization. I'm going to move over here. Alright, so it's going to be f of x equals, and then we have the two factors that we verified. And then that one remaining factor from part B. And then on D, our zeros are a little bit more challenging on this one. So for 2x plus 1, it's not, the zero is not just going to be negative 1. If it, well, we don't have that, but if it was x plus 1, it would just be negative 1. So what do you have to do with that 2? Do you guys know? Divide by it, yeah. So 2x plus 1 has a factor of negative 1/2. What do you guys think about 3x minus 2? 2/3. And then x plus 7 will just be negative 7. Alright, what questions do you guys have? Okay, so your assignment is to finish that 5 through 11 from the worksheet from Thursday. I went ahead and wrote the answers to 5 through 8 on the board. Obviously, you have to show your work, but that way you can just check as you go.